right, so this section, more writing, section 9.2 Implication and Equivalence. So first off, our first definition here is implication. And an implication says that when a proposition P being true means that another proposition Q must be true as well, then you say that P implies Q. So in this you can say if P then Q, and your symbolic form there is going to be kind of a double barred arrow. Now the first proposition is an implication statement called the antecedent, and the second proposition is called the consequent of the statement. I'm not going to really use those words so much, but that's just kind of FYI. If that implication statement is false, or the implication is false when the antecedent is true but the consequent is false, that's because if the first part is true, the second part must also be true. Now, an equivalent statement, if each statement P and Q imply each other, then you must say if and only if P then Q. And in symbolic form, this is P with a double-ended arrow, Q. Now, sometimes you'll see if and only if. People abbreviate that, IFF. I don't care if you do that. So if you ever see that, that means if and only if. Now, in this situation, if P is Q, Q is true. If P is false, Q must also be false. If one is true, the other is false, then P double bar Q is a false statement. Now, let me tell you, too, where we're going with this. Once we get to Section 5, we will have done all of these. If this is true, then this is true, and this symbol and that symbol, and we'll kind of summarize it all in Section 5, and then you will have access to that stuff in your formula booklet, so don't feel like you're going to have to memorize all this stuff. So first, determine the truth value of if it rains on Saturday, then the Highlanders will win, given the following. Okay, so let's say that it is raining on Saturday and the Highlanders do win. So this is consistent with the implicative statement, which is what we were given. P is true, Q is true, so true. So overall, because both parts happened, and that's what the statement said, then it's true. Now, what if it is raining on Saturday, but the Highlanders don't win? Well, this is inconsistent, and we'll just kind of shorten that statement to inconsistent. Because according to our truth value statement here, if it rains, then they win. So P is true, but Q is false, so false. And that's really the only scenario where it is going to be false. The other two are going to be true, but we'll talk about why that is. Okay, so it's sunny on Saturday, and the Highlanders win. This is considered consistent. And basically it's consistent because there was no mention of the outcome if it doesn't rain. So essentially we're saying if it's sunny that it's not raining. So in this case, P is not true, Q is true. Sorry here. Make sure. So the whole thing is true. Basically because I can't prove it false. Okay, we don't know that necessarily just because it's sunny means that they won't win, so we assume that that must be true. And really the same kind of thing on the last one. If it is sunny on Saturday and the Highlanders don't win, well, this is also considered consistent because we don't know what was going to happen if it was sunny. And same explanation, no mention of no rain. So P is not true, Q is not true. So true, again, just because we can't prove it false. That's kind of a little bit weird, and like I said, you'll have that written out so that you won't have to memorize it all, but it can be a little tricky. And I apologize about the writing. I'm trying to get this video done quickly because my computer was not cooperating with me, and the writing's a little sloppy there. I'm sorry. Okay, so consider the following logical propositions here now. So we've got our P statement here is that Isabel is nearsighted, and our Q statement is that Isabel can't see far away. That's actually my daughter's name, and she thought it was really cool that she was going to be in my video here. All right, so we have our symbols. Remember the one-sided arrow, that's our implication statement, and the double-sided arrow, that's our equivalent statement. That's our if and only if. So the first one here, write the following in words. If Isabel is nearsighted, then she can't see far away. Okay, that's all there is to that one. Switch it around. If Isabel can't see far away, then she is nearsighted. Now, it wouldn't matter if you went ahead and put the name back in there, but that's definitely okay there. For C, P, and then now we've got the double arrow. So that's our if and only if. So I'm going to write it out in this case, but in the next one I'm going to use the shortcut IFF. If and only if Isabel is nearsighted, then she can't see far away. Now, sometimes that statement can sound kind of funny. I talked to Miss Cameron about it because I was concerned, and she said sometimes it does, not to really let it bother you. The next one's the same thing, except now we have the word not in it. And again, just because I don't feel like writing out the if and only if again, I'm going to use the IFF. You can always do that, and that's fine. Maybe not on the exam. Write it out just in case someone's not familiar with that. But if and only if Isabel is not nearsighted, then she can see far away. Now, you don't need to underline the word can, but I'm just trying to emphasize the fact that we have to make it opposite. So if it was can't, now it has to be can. And sorry, I'm running out of time here for my video, and I know this handwriting is horrible. Let me try that again there. Okay. All right. So the last part, we're going to just go the other direction, and we're going to do symbols. So let's say that P is going to be it is sunny, and then Q is going to be you must wear sunscreen. So for part A here, we want to do if it is sunny, then you must wear sunscreen. Okay, so sunny, that's my P part. So we're going to say if P, and we're going to write it in symbolic form, but I'm going to write it in words first. I think that might be helpful. Then Q. So in symbols, now that's going to be P and then my single-sided arrow. Okay. For the next one, if you must wear sunscreen, then it is sunny. So that's just going to be the other direction. I'm not going to bother rewriting it there with the colors. We're just going to flip it around. And then the last one, if and only if it is sunny, then you must wear sunscreen. So that's the same order as my first statement, but with the if and only if. So I'm not going to, again, well, I guess I can go ahead and write that out. If and only if P, then Q. So we're going to have P double arrow, Q. Now later on we will have some notation for when it's a not scenario, but let's say that we did the first one there for A, or let's put in a D. Okay, so let's say that D is if it is not sunny, then you must not wear sunscreen. So that's essentially A, but everything is a not. everything's opposite. Now, in that case, then we would say if not P, then not Q. And in the symbols, for right now, you would just do not P, not Q. We'll have, again, a notation for that later on, but we just haven't gotten to that point yet. Now remember, when you say not, it doesn't have to be that there is a not in the question. It's that it's the opposite truth value of what you started off with. So if you started off with sunny, then not P is not sunny. If you started off with not sunny, then not P would be it is sunny. Okay, so that's all of that one. Again, look at the solutions. I tried to give you, our book doesn't have a ton of examples, so I tried to come up with examples elsewhere that I felt like would cover all the bases of what you had in the review or in the homework. I may have missed something. Obviously, again, ask me questions if you have them, but use those solutions that are in Google Classroom and let me know if you've got any questions. You're doing all of this assignment, and again, the book and the solutions are in Google Classroom. The video, obviously, and the notes are in on my website. Okay.